Hello, Mr. Ashfield here. I'm going to be working through 3 past paper questions on maximum mass calculations, and I'm going to be using my favourite MOLES method to work them out. I'm going to go through them pretty quickly, so if you need to, pause the video at any point and you can try and work out the rest on your own, or you can work out what I've done if you think you've done something different. Okay, so question 1. Butene reacts with steam to produce butanol. Calculate the maximum mass of butanol, C4H9OH, so I'm going to underline that and that in the question. That can be produced when 1.4 kilograms of butene, C4H8, I'll underline that, reacts with excess steam. So steam is in excess, I don't need to worry about how much H2 there is, I'm just worrying about these. So number 1, I need to work out the moles of C4H8. Moles equals mass divided by the RFM. So that is going to be the mass of C4H8. I've got 1.4. Don't worry about the kilograms unless it asks you for a different unit at the end. So 1.4 is my mass divided by the RFM, which is, so what's 4 times 12 plus 8 times 1. So 4 times 12 equals 48 plus 8 gives me 56. So I'm going to write 56 down here. 1.4 divided by 56 gives me 0.025 moles of C4H8. So I now need to look at my ratio between C4H8 and my product of C4H9OH. I've got one of these for every one of these, so my ratio is 1 to 1. So if I've got 0.025 moles of that, I'm going to make 0.025 moles of this. How much will that many moles weigh? Well, if I rearrange this equation, mass equals moles times RFM. So my mass of C4H9OH will equal 0.025 moles times by whatever its RFM is. The RFM is going to be 4 times 12 plus 9 plus 16 plus 1 is 17. So 4 times 12 is 48, plus 9 plus 17 gives me 74. So moles times mass, moles times RFM gives me the mass of, that times 0.025, 1.85 grams. Does this make sense? Well, this weighs, the RFM of this is 56, the RFM of this is 74, so this is about, I don't know, half as heavy, a third as heavy again, and we've got it from 1.4 to 1.85, so yeah, that answer looks sensible to me, so I'm going to keep it. Question 2. So, iron ore contains iron oxide. Iron is extracted from iron oxide. I'll just move the camera, sorry. There we go. Iron ore contains iron oxide. Iron is extracted from iron oxide by heating the oxide with carbon. The formula for the iron oxide is Fe2O3. Calculate the maximum mass of iron that can be obtained from 240 tons of iron oxide. Fe2O3. So I've got my Fe2O3 over here. I'm going to write that you need a balanced equation, so I'm going to balance the equation before I start the question. Makes Fe plus CO2. Right, so I've got 2 ions over here, so I'm going to need 2 ions over here. So I'll put a 2 there for now. I've got 1 carbon, 1 carbon, 3 oxygens and 2 oxygens. Easiest way to balance that is going to be to get to 6. So if I have 2 of those, I will have 3 of those, so that will give me 6 oxygens. I've got 3 carbons, so I need a 3 over there. And if I've got 2 Fe2, that's going to give me a 4 in front of the ion. Right, let's start working out. What are my moles of what I start with? Moles of Fe2O3 equals mass divided by RFM. What's my mass? Tells me it's 240 divided by RFM, which Fe2O3 is, I've got 2 lots of 56, which is iron, and I've got 3 lots of 16. So what is 2 times 56? It's 112 plus 3 times 16, 160. So 240 divided by 160 gives me 240 divided by 160. That gives me 1.5 moles of Fe2O3. We need to look at the ratio next. So I've got 2 Fe2O3 to every 4 Fe. What's that ratio? That is a ratio of 1 to 2. So if I have 1.5 here, I'm going to have twice as many over here. So 2 times 1.5 times 2 is 3 moles of iron. What's my mass of iron? The mass of iron is going to be my moles times by RFM, which is going to be 3 moles times by the RFM of iron, which is 56, gives me 3 times 56, 168. Moving on to the last one. So, in a different electrolysis, molten sodium fluoride is decomposed. Calculate the maximum mass of sodium that could be formed from 168 grams of sodium fluoride. Right, if you don't know what electrolysis is, or you've forgotten what decomposed means, it doesn't matter. It's told you it's a maximum mass calculation, and it's given you an equation. So I'm going to start by underlining the important bits. It says sodium, there's sodium. That could be formed from 168 grams of sodium fluoride. So I need to work out my moles of sodium fluoride. Moles is mass divided by RFM, which is 168 grams divided by 23 plus 19. So sodium is 23, fluorine is 19. 23 plus 19 is 42. So 168 divided by 42 gives me 4. So that's 4 moles of sodium fluoride. I need to look at my ratio next. Sodium fluoride compared to sodium. I've got 2 NaF for every 2 sodium. So if I've got that's the same as a 1-to-1 ratio. So I've got 4 moles of this. I must make 4 moles of this. What is my mass of sodium? My mass of sodium is equal to the moles multiplied by the RFM. So I've got 4 moles, and I multiply it by the RFM of sodium, which it says is 23. So 4 times 23 is, I'll check out my calculator, 4 times 23, 92 grams. Apologies, that was off the camera. Right. So that should be clear enough for you. Hope it's been useful. Ta-ta.